Hello friends, in this video we will be learning a very important topic from convolution point of view, that is impulse response. Impulse response is the important fundamental that you must understand if you want to be quite comfortable with convolution. Let us begin. As the name suggests, impulse response means it is a response given by system in response to impulse input, right? So what we are studying here, it is specially for discrete time system. The output of system when input is unit impulse is known as impulse response. As you can see, this is some discrete time system to which del of n is applied, okay, in response to which you are getting some output, and that output is a response provided to input as impulse. So therefore this is called as impulse response. So h of n is called as an impulse response and del of n is called as unit impulse input. We know that how del of n looks like, and also in the form of sequence we write it this way. We know that an arrow mark indicates the sample position at n equal to 0. So when I start drawing this del of n, it is having amplitude 1 at n equal to 0, and it is always 0 otherwise, am I right? So this is the kind of input if I apply to a system, then the output given by the system or response given by the system is called as impulse response, that is response given to an impulse input. Now the question is, why to apply an impulse input, and thereafter once you apply an impulse input, the output that you get is what we called as an impulse response, and why impulse response is very important for us. So now we are going to see advantages of impulse response h of n, especially for LTI system. So when I say LTI system, it means it consists of two inherent properties, that is, it is linear as well as time invariant system. I'm sure you must have seen the previous videos where I have made you understand very clearly what are linear systems and what are time invariant systems. So linear systems are those systems which follows additivity as well as homogeneity principle, whereas time invariant systems are those systems which can be described this way. For example, if you apply input as x of t and let's say output is y of t, then if you delay the input, let's say by t naught amount, so this time let's say you are applying x of t minus 1, then output must be y of t minus 1, meaning that the quantity by which you are going to delay your input, by same quantity your output should also get delayed. In fact, time invariant systems are those systems whose properties do not change with respect to time, they remain same. So why do we study LTI system? Because LTI systems are considered to be ideal systems. Let me tell you, when you get into practical systems, they are quite non-linear as well as they could be time variant system also. But then we study non-linear systems and time variant system when we learn advanced control system, or whenever you will go to masters, there only you will be studying those systems, that is non-linear systems as well as time variant system. According to GATE syllabus, we are going to concentrate only on those systems which are linear in nature as well as time invariant in nature. So a system with both properties is called as LTI system. So the discussion over here is limited to LTI system only. So first of all, you can see h of t completely characterizes LTI system. So what is meant by it completely characterizes LTI system means h of t is going to tell you a complete behavior of the system. So first note that it tells you about behavior of the system. You also understand the causality of the system, means if the system is causal or non-causal. So you understand a causality also. Along with the causality, you understand a stability of system. You understand whether systems are static or dynamic. Also, from h of t, you can determine whether the system is invertible or non-invertible in nature. So you understand whether your systems are invertible or not. So these many things, this much information is given by alone h of t. So for a particular LTI system, if h of t is known to me, I can characterize a complete system, whether it is causal or non-causal, whether it is stable or unstable, whether it is static or dynamic. Also, we will understand whether it is invertible or non-invertible in nature. See, a single h of t is going to tell you these many things about LTI system. Yes, when it is non-LTI system, then only h of t is not enough. We require other parameters also to characterize that system. But when it comes to LTI system, h of t is enough to tell about a system, that is in and out about the system. The second advantage says finding output of LTI system for any input x of t. Okay. For example, let's say if h of t is known to you. Now you know that what is h of t? H of t is called as impulse response. So for a particular system, let's say if h of t is known to me, and let's say you are applying some input x of t, then you can determine what is y of t, where y of t is x of t convolved with h of t, because x of t is an input that we are applying from our interest. H of t is an impulse response. It is in advance, let's say, known to me. So it is quite possible for us to derive y of t mathematically by using y of t is equal to x of t convolved with h of t. Now the sign over here, that is an operator called as a convolution operator. Right now, I have used notations as x of t, y of t, and y of t is equal to x of t convolved with h of t. It clearly indicates I'm talking about a continuous time signal system, right? But yes, of course, you can have the same property in discrete time sense also. So instead of x of t, you will have x of n. Instead of h of t, you will have h of n. And instead of y of t as output, you will have y of n. And relation remains same. That is, y of n will be x of n convolved with h of n. So it really doesn't matter whether you are working with continuous time system or discrete time system. Relation between input, impulse response and output remains same. So what it means that if impulse response is known to you, it is possible for you to find the output for any input, right? Third and very important conclusion, that transfer function is obtained by using impulse response only. If you have done control system, you must have learned about transfer function. So that transfer function is what we call as h of s. So if you have an impulse response, let us assume h of t. If you take a Laplace transform of this, you get h of s. So h of s is called as a transfer function. And using those transfer functions, let's say if it is transfer function of a closed loop control system, you can determine the closed loop pole's location, and from that also you can identify whether system is stable or unstable, right? Also you can characterize the system. I mean, you can find limitations on the gain of the system for which system will be stable by using many tools like a root locus and all. But for that you must have a transfer function, and if you want a transfer function, it is basically obtained by having a Laplace transform of h of t only. And suppose in this h of s, if you let's say substitute s equal to j omega, then it becomes h of j omega. So this is the another way to get h of j omega by using substitution as s equal to j omega, or from h of t also you can get h of j omega by having a Fourier transform. So Fourier transform is the another tool by which you can get h of j omega, and the use of h of j omega is to know the frequency response of the system. So h of j omega is used to study frequency response of the system. Using this frequency response, you can have two categories, that is a magnitude response and a phase response. So magnitude response tells you how magnitude of the system is changing with respect to frequency, and how phase is changing with respect to frequency. It is obtained with phase response. So as you can see, just one response, that is impulse response, has so many advantages, right? So studying impulse response is very important. because if you don't know what is impulse response, then it is impossible to have transfer function h of s, or it is impossible to have h of j omega, which makes you capable to study frequency response of the system. So now read the question. Find mathematical representation of x of n in terms of shifted impulses, and some x of n sequence is given. You know that. What is the significance of the arrow mark? So significance of arrow mark is that this is the sample present at n equal to 0, 6 is present at n equal to 1, 4 is present at n equal to 2, then 0 means there is no amplitude present or 0 sample present at n equal to -1. This is present at n equal to -2. This is present at n equal to -3, and finally this 1 is present at n equal to -4. Is that right? So now to express a mathematical representation of x of n in terms of shifted impulses, we need to do a little exercise. So what I meant, suppose you have a random sequence like this. Let's say 0, 0, then you have 1, then you have 0, 0 here. And let's say if I'm showing an arrow mark here, I'm sure you must have recognized that only at n equal to 0, a signal is present having magnitude equal to 1 or amplitude equal to 1, and it is equal to 0 when n is not equal to 0. So only at n equal to 0, if some sample is present, then this is of course known as what? It is known as an impulse input del of n, because we know that del of n is equal to 1 only at n equal to 0, and del of n is always 0 when n is not equal to 0. Now suppose if I modify this to, and let's say we have an arrow mark here, then what does that indicate? Of course, now only at n equal to 0, some sample is present having amplitude equal to 5, right? In that case, you can write it like this, 5 del of n, because ultimately sample is present only at n equal to 0, but this time amplitude equal to 5, then you can say it is 5 times del of n. Now for example, you have this kind of response or this type of input sequence, and again at n equal to 0, it is having amplitude equal to -2, then you can write this as -2 times del of n. Is that right? Now for example, we have this kind of response. Now what does that mean? An arrow mark indicates n equal to 0 position, and this 1 is present at n equal to -1 position. Is that right? So now you can express in terms of impulse input or in terms of impulse signal like this, del of n plus 1. We know that. What is meant by del of n plus 1? Del of n plus 1 means an impulse present at n equal to -1 position. Am I right? And again, since it has got amplitude equal to 1, I have kept coefficient equal to 1 only. So this is what we call as a coefficient. So if the coefficient is 1, there is no need to write 1 also. For example, let's say we have this type of sequence. Then how do we express this? We know that an arrow mark indicates it is a sample present at n equal to 0. Is that right? This is the sample present at n equal to -1, and this is the sample present at n equal to +1. So for n equal to -1 sample, we write it in this way, that is del of n plus 1. Is that right? Now coefficient is 1. Then at n equal to 0, sample position amplitude is 5, or sample amplitude is 5 at n equal to 0. I can write plus 5 times del of n plus, now for 3 I can write 3 times del of n minus 1, because this is a sample position having an amplitude equal to 3 present at n equal to +1. So I can write n minus 1. So this is how for a given sequence we can express it in terms of shifted impulse input, because these are called as shifted impulse input, because this is what we called as an impulse, but this is called as a shifted impulse. This is also a shifted impulse. So this is shifted in the sense it is delayed by 1, and this is shifted in the sense it is advanced by 1, and this is present at n equal to 0. So this is only called as an impulse, meaning that if some sequence is given I can express that sequence in terms of shifted impulse input summation together. Am I right? So now I'm sure it is quite easy to express this x of n in terms of shifted impulse input. So let us try that also now. So I'll be starting with extreme left, that is n equal to -4 position. So at n equal to -4 position, it is having signal magnitude or signal amplitude equal to +1. So coefficient is 1. So I can write 1 del of n plus 4. Is that right? Because if sample position is present at n equal to -4, you write del of n plus 4. Then another sample having amplitude equal to 2. So you will say plus, having an amplitude equal to 2. Del of position is n equal to -3. I supposed to write n plus 3. Then you have to consider this sample, that is having an amplitude +3. Then coefficient is +3. Present at n equal to -2 position. Then I supposed to write del of n plus 2. After that, you are having no sample. Okay, when they say amplitude equal to 0, it means there is no sample present at n equal to -1. It means the coefficient is 0. So you can write like this: 0 times del of n plus 1. But then it is quite not needed to write if the sample position is 0. So you don't have to express for a sample whose amplitude equal to 0 there. Then I can write it for -1. So I can write -1, and -1 is present at n equal to 0. So I can say -1 del of n. Then for 6, I can write +6. See, it depends upon the amplitude. If the amplitude is -1, I'm writing coefficient as -1. If the amplitude is +6, I'll write coefficient as +6. Present at n equal to 1 position, I supposed to write del of n minus 1. And last, having amplitude 4, present at n equal to +2, I supposed to write n minus 2. Is that right? Or else I can write it this way. So I'll take one more example and I'll conclude this. Let me have another sequence x of n as so let us try to express the given x of n sequence in terms of shifted impulse input. So now I'm sure it is easy for you. So this is the position at n equal to 0. Arrow mark indicates it. This is n equal to 1, n equal to 2, and this 3 is present at n equal to 3. 2 is present at n equal to -1, and 1 is present at n equal to -2. So you should always start with from extreme left position sample. So now I can write x of n equal to, first of all, amplitude is +1, coefficient is +1. I can write del of n minus 2, means I have to write +2 here. Then coefficient is +2, del of n plus 1. Then at n equal to 0, amplitude is -4, therefore coefficient is -4, del of n, because it is present at n equal to 0 position. Then amplitude is 5, then I supposed to write +5, del of n minus 1 for n equal to 1. Then we have amplitude 6, so I'll say +6, del of n minus 2. And last, you are having an amplitude equal to 3, I'll write 3 times del of n minus 3. Is that right? So now I'm just doing little modifications in the same. If you observe carefully, this -4 is nothing but x of 0. Am I right? Because x of n at n equal to 0 is -4. I can replace this 5 with x of 1. I can replace 6 with x of 2. I can replace 3 with x of 3. X of 3 means x of n at n equal to 3. As you can see, x of n at n equal to 3, it is 3. Or x of n at n equal to 0, it is -4. So this 2 is a coefficient which is nothing but x of -1, and this 1 is nothing but x of -2. So I'm rewriting x of n, x of -2 dot del of n plus 2 plus 2. I should replace 2 with x of -1 only. So x of -1 del of n plus 1 plus x of 0. Okay, you can write plus here because value of x of 0 is -4. So ultimately it will become -4 only. Del of n plus x of 1 del of n minus 1 plus x of 2 del of n minus 2, and finally plus x of 3 del of n minus 3. Is that right? Now, if you observe carefully, here it is minus 2, then it is plus 2. Here it is minus 1, then it is plus 1. If it is 0, then nothing is present here. If it is 1, it is minus 1. If it is 2, it is minus 2. If it is 3, it is minus 3. What I really mean to say is, I need to write it in a short. So I'm able to do this. If you see, it is actually following a common format everywhere. Is that right? So it is following a common format everywhere. And then it is summation of all together. So I can write some summation symbol here. And if you see the value of variable here and here, it is same. Here and here it is same. So I can replace with another variable, let's say k. So I can write this as x of k dot del of. Now if this is minus 2, then this is plus 2. So if I say plus k here, I need to say it is minus k. So I can write n minus k. Is that right? And as you can see, the value of k, okay, the starting limit is minus 2 and the highest limit is plus 3. So I'll be varying my k from minus 2 to plus 3. So I can represent my x of n in the form of this, that is x of n is equal to summation where k is varied from minus 2 to plus 3, x of k dot del of n minus k. But do you think that every time your discrete time sequence is starting with n equal to minus 2 and ending at n equal to plus 3? No, it is not so. It is going to vary depending upon the size of signal, depending upon the length of signal. So if the signal varies, this expression is going to vary. But not expression, but I'll say only lower limit and higher limit will vary. So I can write it in general. I can write x of n as summation. I'll say k equal to minus infinity to plus infinity. I'll write x of k dot del of n minus k. This expression is very, very important. If you are able to understand how this expression has come, then let me promise you, a convolution will be a much interesting topic for you. If you are able to express the given discrete time sequence in the form of the shifted impulse input in this form, then it is quite easy for you to understand convolution. Thank you.